Okay, so today we are looking at position time graphs and we are calculating instantaneous velocity. What do you think that means? Instant. How fast it's going?
Right now.
Right now. If you look down at your speedometer of your car, it's how fast you're going right now when the police go past you. They care how fast you were going before? No. Your average velocity? No. How fast you're going right now? That's what matters. Okay, now what have we done already? We have determined displacement from a DT graph. Do you remember doing that? We read 2 points off the graph and we subtracted. We determined average velocity from a DT graph by dividing the displacement by the time interval. And there is our graph. So, as a little review, let's do that again before we jump into instantaneous. Okay? So I want you to find a displacement and average velocity for those intervals. And yes, some of you know how to do it. I'm good with that. You might think, I don't need to do this again. I know how to do this. Practice. Practice. There should be 6. A, B, C, D, E, and F, and I think I've labeled them nicely this time, haven't I?
Yeah.
Okay. Shall I do the first one as a refresher?
Yeah.
For some people? Okay, sounds fine. 0 to 2 seconds. So the displacement is going to be, I go from 0 to 6. So the displacement's going to be 6 minus 0, or 6. And the average velocity is d over t, which is, what's the d? 6. What's the time? 2. You don't even need a calculator for this, you guys. Did I just find the slope of the line?
Yeah.
Yeah, I sure did. You guys did slope and math? Okay.
Yeah, we should have got studied way.
Well, did we do rise and run?
It's better. I know.
Well, we did. This is easy because you already know it, probably. Right? Try B. Try B while I go mark attempts. Should I do just B and C silently up here?
I'm done.
Or should you want to wait and see them all? Displacement is minus 16. So the velocity is going to be d over t minus 16. How much time? From 6 seconds to 10 seconds is 4 minus 4 meters per second. That's all there is to it. What's the slope? Minus 4. D, again, 0 and 0.
Equals 0.
E is really steep. The final is here at minus 4. The initial was at minus 10, so it's subtract minus 10. Minus 4 minus minus 10 is plus 6. Minus 4 is overall plus 6, right? Displacement is plus 6. Velocity is 6 over 1. Hopefully you didn't need a calculator for that. You did by accident. Does the fact that F is curved matter? You know from yesterday that curved lines means that it's not moving at a constant velocity, it's actually speeding up or slowing down, but does it matter? And the answer is no. The displacement is 0 minus minus 4 plus 4, and your velocity is 4 over how many seconds? 1, 2, 3, 4, 5. 0.8, that's a 5, 0.8 meters per second. What I really did there was I actually drew this line there. Oops, I didn't draw it very well. And you're finding the slope of the line that joins the endpoints. Okay? All right, so let me just read this. In the graph, the slope of the line in time interval A would yield the average velocity for that time interval. In general, average velocity is the slope of the line joining the endpoints of the time interval. Put a star beside that because it's important. In general, the average velocity is the slope of the line joining the endpoints of the time interval. This is true for straight lines and curved lines like interval F. Do you not have that there on the side?
No, we had to fill in the blank.
Oh, fill in the blank at the bottom? Okay. So fill in the blank at the bottom of the page there, where it says in general, right? I probably want you to fill that in because it's kind of important. Average velocity is the slope of the line joining the endpoints of the time interval. If you're one of those ones that's sleeping in Professor Bennett's class, time to wake up. What? Oh. Here's the number one big physics idea for the day, the unimportant thing. Instantaneous velocity is the slope of a line at a single point. The slope of a line at a single point. Now, when you did slope in math, you always needed rise over run, y2 minus y1, right? 2 points, all that nonsense, right? Okay, how the heck do you find the slope at a single point? Well, one of the ways to do that is to go and take Professor Mendelssohn's class, Honors Calculus.
What is honors?
I was stupid making that decision. Calculus at the U of M, when I was there, was broken into two parts. There's like 2 half credits, right? First semester calculus, second semester calculus, right? And then there's like a midterm and a final in there. Well, I, being the idiot that I am, thought I was Mr. Smarty Pants, and I thought I'd take honors calculus, which was those 2 courses put together in one for the whole year. But instead of like midterm final, it was midterm final. Very smart. Got a C.
You got the credit?
Yeah, I got the credit, but I got a C. Wow. Not on the ABC. Yeah. Maybe a C plus. Yeah, I don't know. It was hard.
How did you get on the final then if you got 100 on the...
No, that was a different class. That was linear algebra. Yeah. The final linear algebra I got like about a 75 or whatever because I didn't spend the entire weekend studying because I went to class and I didn't waste my entire weekend learning math. No one wants that. That's the point of that. No one wants to spend the whole weekend learning math. Okay, anyways, back to this. Instantaneous velocity, the slope of a line at a single point. It's easy for straight line segments A, B, C, D, and E. How come? Because the slope there is the same as the slope there, is the same as the slope there, is the same as the slope there. You just find the slope. Like the slope of the line doesn't change. How come? They're straight. So it's no big deal. But and vinst is the slope of the line since the slope remains constant. That's what I'm saying there, right? Do you have that right there? Okay, now, the hard part is the slope of a line at a single point when it's curved. For curved line segment F, vinst is the slope of the tangent line. The slope of the tangent line. What the heck does that mean? Confusion, emoticon. Huh?
What the heck is that?
I was told that was the I'm confused emoticon.
Why is it like a...
Eh? Does look like a bit like a pirate.
I thought...
Reminds me of my old milkman that delivered the milk that had the hook on his hand. It was scary. When you're 4 years old and the guy comes to your house every day with a hook, delivering milk, that's scary. Anyways, the slope of the tangent line. What is a tangent line? Do you know?
No.
The straight line from the start to the end.
No, like this, Bill?
Like you put 2 ends on the end of the line and the beginning.
Like that?
Yeah. Is that it?
Afraid not. Good try though. I'm okay with that. That is not a tangent line. A tangent line is a line like this. Okay? See how we've got a curvy blue line and then you got this straight green line. This straight green line is the tangent line. It only touches the curve at one point and it estimates the curve at that single point. Or approximates. That's what the professors like to say. It approximates the curve. So the curve of this green line, and I can't do green, I got to do red. The curve, the slope of that red line there, green line, is the slope right there. Well, what is it up here? Well, it would be steeper, wouldn't it? Right? So you have to do your best with a ruler and sort of estimate.
So you have to figure it out and draw it?
You got to draw it. You got to draw the tangent line and then do what? Which is find the slope. How do you find the slope of a line? Yeah, pick 2 points. Does it have to be the end points? No. Here it just happens to be, whatever. Okay, so what's the slope here? Well, this point is at 9 and 10, so it's going to be 10. The y is 10. Here the y is 2, so 10 minus 2 over 9 minus 5, which is 8 over 4, and we don't even need a calculator, 2 meters per second. The slope of the green line is 2 meters per second. That's the slope of the blue curve at that instant, dot. If you went further up the blue line, you would get, let me do it again, if you went further up the blue line, you would need a steeper slope, you would get different points, and you'd get a steeper slope. If you went down the other way, well, you'd get flatter, wouldn't you? Is Graham's and Lane, what are you doing? Are you posting on Yik what a great job I'm doing?
Yeah, actually.
Good. Are Graham and Lane going to get exactly the same numbers?
Nope.
Well, they might, because they're sitting side by side. And that's okay. But are Billy and Peter, are they going to get the same?
No.
Probably not. And is that okay?
Yeah.
Yes, it is an estimate. What do I need to see to give you a check mark? Yeah, they know what they're doing. I need to see the line. You got to draw the line. And I need to see the points that you're using in the work.
So how do you know which one you draw the line?
Yeah, where do you draw this line?
Okay, so I would say, like, the question here would be, like, what would be that time? Maybe 6, right? So I would say, what's the instantaneous velocity at 6 seconds?
It's like the question literally just going to be a curved line. You just draw a line here.
It'll be a curved line, and I'll say, what's the instantaneous velocity at 6 seconds? You draw the tangent line at 6 seconds to your best ability. Draw it as long as you need to. Find 2 points that you can come up with. Give me the slope, and there's your answer.
I think we just might take some time.
You just got to sort of guess. I mean, it's only going to touch it at one point. Like, is that a good tangent line for that point? No. It's got to do what? It's got to just kiss up to it, and like anywhere from about there to about there, I would sort of allow, right?
So it's like
That's a small window.
Well, come on. It's really not that hard. You guys are worried. When the DT graph is curved like this is called variable motion. Blaine, what's a variable from computer science? Come on, man.
That's like grade 9.
Connor, what's a variable in computer science? It's a word that could represent any number, right? This is variable motion because the motion or changes. In this case, speeding up or slowing down. Oh, it says it right there, since the velocity varies.
It's right down here.
When the DT graph is curved like this, it's called variable motion. Okay, you're going to have an opportunity now to practice this.
Right now.
On the next page, you should have this, do you?
Yep.
Okay, go ahead and tell me what's the instantaneous velocity at, I guess this would be, I don't know.
Can the tangent line be on the left side of the...
Oh, yeah. Yeah, like you're going to draw it up over here, right? Yeah. Okay.
It's not allowed to go through that.
It's not allowed to, it can, Lane, like, it can go through it, like when the slope changes here, like say for example, this went up like this, right? Okay. Is that allowed? Well, yeah, because does this have anything to do with down here?
No.
No. It's allowed to do that. It just can't go through it like down there, kind of thing, right? Like there's some judgment involved. Okay, I'm going to leave that back up there so people copy that down, but those of you that are doing the practice, go ahead. And yes, do it. How does that look for a tangent line? Are you comfortable with that? That's pretty close, right? You know what? I wouldn't mind it being a little steeper.
Well, you don't have to make.
It's a little easier with a ruler, I find, than up here. Okay, so I've drawn the tangent line, and now you got to pick. Does it have to be the endpoints? No. Right? And here there's no grid, right? So it makes it even more of a challenge, right? Like I'm just going to do this. I'm just going to pick that point right there. I'm going to say this point here is at 6, 22. And can I use the 0 point? Why not? Let's use that one. So that would be at 0, I'm going to go with 9. Okay, so my slope, my velocity is going to be y2 minus y1. So y2 is 22. 22 minus 9 over 6 minus 0. 22 minus 9 is 13 over 6, 2 point something or other. Am I right? Did I do that right? I got 2.2 meters per second.
It's right. I got a negative.
Would you say?
You should definitely not get a negative.
Would you say 2.5 is?
Oh yeah, like anywhere literally from about 1.5 to almost 3, especially when I haven't given you a grid like that, is acceptable. The answer doesn't matter. What matters is you drew a tangent line and you showed me the slope calculation. You know what to do. I don't care about this number. I look at it as if it's negative, I'm going to have to mark it wrong, because clearly it's positive slope.
How did I get a negative?
Did you do something backwards or something
Because you do 0 minus 10.
there? Yeah.
Yeah.
You do 10 minus 0.
Yeah. There you go.
It's x2 minus x1.
This is the x1 x2 y2.
30 and 10.
This is the x1 y1.
Corner. No, 30 and...
Wait, 10 and 3.
Want to try this one? It's the same graph, just at a different point, right? Same graph, different point. Go ahead, try that.
2.3.
I have an answer of 1.75.
That answer is 2.42.
No, I answered 2.
Anywhere between about 1 and about 2.5 or so is perfectly all right. As long as you have a tangent line, 2 points, and the slope calculation.
0.69.
0.69? Yeah, that's a little on the low side. But again, if you got two good, I mean, a lot of the time it depends on what tangent line you draw. If you're not a very good tangent line drawer, you're going to have to practice that, I guess, right? Okay. This one here. Now, can you do this? I can't remember how I put this together. I would like...
It's the exact same as that.
It's the same as that, right? Okay. Can you pull this sheet out? Actually, okay, I'm going to check that tomorrow. I want you for tomorrow. You can keep it. I don't want it. I'll check tomorrow. I'll come around. Give me the vinst at 1, 2, and 3 seconds. You got 3 to do on that curve there. There's a bit of a grid. vinst stands for instantaneous velocity. What you were just doing. So you have to do that for 1 second, 2 seconds, and 3 seconds. Should the numbers be going up?
Yes,
How come?
because you're going.
Because the slope is getting steep. That's your job for tomorrow. Have that done. There are some more practice ones there. That's what we're working on tomorrow.
Have it done for tomorrow.
Have those 3 done for tomorrow. Those 3 circled ones.